Hi again. In this video we'll take a look at detecting a collision between a point and a rectangle. Now in processing, when we use the rect command to draw a rectangle, if you look at the ref you'll see that there are a few different ways it interprets the arguments depending on what the rect mode is set to. In this program I'm setting rect mode to center so that we're going to define the x and y center point of our rectangle. So if we look at my variable declaration, you can see right off the bat I've declared I'm going to have an integer for the x position and an integer for the y position. If we jump down to where the rect command is called, you can see that I'm also giving a third and fourth argument of a width and a height. Now we obviously can't use the full word width and height because those are reserved words in processing, so we'll just use w and h. I've also put in 4 additional variables: the left, the right, the top, and the bottom. And while we don't need to know those values to draw a rect on the screen, they are important for determining a collision. Now let's initialize these variables and get the rectangle drawn on the screen. Let's start by setting our x and our y value to the classic width divided by 2 and height divided by 2 to center it on the middle of the canvas. And we'll say the width, let's make it equal to 200, and the height, let's make it equal to 75. Now, left is referring to the x value of the left edge of our rectangle. And we can build an expression based on what we already know. The left x value is simply going to be equal to our center point minus half of the width. Similarly, the right-hand side is going to be equal to our center point plus half of our width. And we can use this same logic to also determine the top and the bottom. And that's going to be our y value of the center point, subtract the height divided by 2, and the bottom is going to be equal to the center point y component plus the height divided by 2. Now that we've initialized these values, this rect command has 4 variables that have information in them, and if we run this program we should see we've got a rectangle on the screen. So now let's consider a strategy for determining a collision between a point and a rectangle. The solution we used for a point in a circle compared the distance between the center point and the point, but it's easy to see that this type of approach won't work in this context. However, our algorithm will still be quite simple. The main pieces of information that we need are the x and y coordinates of our point, as well as the x position of the left and right edges of the rectangle, and the y positions of the top and bottom edges of the rectangle. We can create a series of comparisons that will narrow down whether or not we have a collision. Our first comparison will be to see if the x position of the point is greater than the left edge of the rectangle. If it's not, we don't need to do any more work, as this establishes that there is no collision. If this condition is true, though, we have the potential of a collision and should investigate further. The second step is to verify that the x position of our point is less than the right edge of the rectangle. If it is, we have shown that the x values of the point and the rectangle intersect. Our third and fourth steps follow the exact same idea, this time ensuring that the y position of the point is greater than the top edge of the rectangle, but also less than the bottom edge. If and only if all 4 of these conditions are true, there is a collision. Now we could implement this as 4 separate nested if statements or one long compound conditional. What I'd like to do is to group it by x's and y's. That way we can test to make sure that each of those components are working separately. So let's just write the pseudocode for the x component, and just like we just discussed, we're going to say if the x value of the point is greater than the left edge and x, I'll just say x of the point, is less than the right edge, then we have a possible collision. So to implement that in code, we will simply use our mouse x as the x value of our point. We're going to say if mouse x is greater than our left value and mouse x is less than our right value. And before we complete the whole thing, let's just make a change right here. So we'll just pick an arbitrary value for a new color. So that if our partial condition here succeeds, that our rectangle, before it's drawn on that particular frame, should be changed to be a different fill color than white. So let's just run this and see how our partial solution works. Now we see if we move our mouse over the rectangle, we see a collision. Now, as you probably predicted, it isn't checking anything about the vertical position of our mouse. So it's just showing us that we have a left-right intersection, which isn't a complete solution, but it's a pretty good start. So let's close this and add the second half of the algorithm. We'll just write it in our pseudocode again first. We can say if the y value of the point is greater than the top and the y value of the point is less than the bottom, then we definitely have a collision. So to implement it, let's put it in code, and our y value of the point is, in this case, our mouse y. So we want to say if we're greater than the top and if the mouse y is also less than the bottom. And then we'll just put in the script brackets and indent appropriately. Maybe just space that out a little bit. Now when we run our program, it will first check if we have a left and right intersection or collision. And if that's true, we'll do this second check that also determines whether or not we have a vertical collision. And the order of these isn't important. The main thing is that all four must succeed in order for there to be a true collision. And as we test our program, we can see now that whenever we move the mouse to the box, that the fill color is changing. And there you have it. Collisions between a point and a rectangle.